Two of the roots of the equation, z to the 6 plus 8i equals 0, lie in the second quadrant of the complex plane. If these two roots are represented by a and b in the complex plane, determine the complex number represented by the midpoint of AB, and we want to give that in Cartesian form. So z to the 6 is equal to negative 8i. So that would be down here. So z to the 6 is going to be 8 cis 3 pi by 2. That means one of the six roots of this would be 8 to the 1/6, which is root 2, cis 3 pi by 12, which is the same as pi by 4. We have 6 roots spread around 2 pi, so the gap between them would be pi by 3. The two that we're after, ZA, would be root 2 cis pi by 4 plus pi by 3, which is root 2 cis, put them over 12, 7 pi by 12, and the other one we'll add on another pi by 3, so that's 4 pi by 12, giving us root 2 cis 11 pi by 12. Now, since these roots lie on a circle, and we're talking about one here and one here, it stands to reason that the midpoint would be here, and this angle here would be pi by 6. Now we know that this length is root 2, and this is a right-angled triangle, so if I just call this D for the moment, then we know that cos pi by 6 would be equal to D over root 2. Cos pi by 6 is root 3 over 2, so that's equal to D over root 2. So it follows that D is equal to root 6 over 2. Now, it's clear that this point is halfway between these two angles. So at 9 pi by 12, or 3 pi by 4. So this point that we're after has polar form root 6 over 2, cis 3 pi by 4. So that's root 6 over 2 cos 3 pi by 4 plus I sine 3 pi by 4. Now, the cosine of 3 pi by 4 is negative root 2 over 2, and the sine is root 2 over 2. So that gives us negative root 12 over 4 plus I root 12 over 4. Don't forget, root 12 is equal to 2 root 3. So we can cancel this down to minus root 3 over 2 plus I root 3 over 2.